Hello and welcome to our lesson on 4C.2 logarithmic equations. So we can use laws of logarithms to write equations in a different form. This can be particularly useful if an unknown appears as an exponent. Like we said in the last video, that last logarithm law is very important. For the logarithmic function, for every value of y, there's only one corresponding value of x. So we can take the logarithm of both sides of an equation without changing the solution. We can only do this if both sides are positive. We can't take logarithms of negative numbers. So, for example, if I want to write this as a logarithmic equation, I could take the log of both sides and write log of y equals log of 20b cubed. Then I could expand this a little bit and say, break this down into log of 20 plus log of b cubed. And if I want to, I can drop that 3 in front of the log b. Now, this doesn't seem so useful in this form, but we're going to use this for other purposes later. Likewise, if we have this expression here, we can take the log of both sides. So log of f times log of 20 over root n. Then I can use the subtraction law to say this is the same as log of 20 minus log of root n. If I like, I can rewrite this root n as n to the 1/2. And I could drop that 1/2 in front of the log n if I need to. We can also use that principle to write an expression with lots of logarithms without logarithms. So for example, here I've got logs all over my equation, but noticing that they have the same base, I can start by combining these two together. I can keep log base a and do 5 divided by t. And then when I have a single logarithm equal to a single logarithm, I can say that this log base a part can be eliminated, and I can just say that the value here must be equal to the value here, so f must be equal to 5 over t. So combining logs into a single logarithm might be useful to help us solve an equation or rewrite it. Likewise, here I have logs on both sides, single logs. I'm going to start by bringing this negative 1/3 factor up as an exponent. Now I have a single log equal to a single log with the same base, which means that their values must be equal. N must be equal to p to the negative 1/3. Okay, and over here, we can use that principle to help us solve for x. So we can have a whole bunch of logs here. We can combine them into a single log. Noticing they all have the same base, I can combine the right side into a single log, keeping base 5, and taking 8 divided by 6 minus x. Now I have a single log equal to a single log, which means the values must be equal, or x must be equal to 8 over 6 minus x. And I can solve for x. I can multiply both sides by 6 minus x, expand, bring everything to one side, all my terms to one side. And notice I have a quadratic equation, so I'm going to factor it. And when I factor it, I see that either x minus 4 must be equal to 0, which means x is equal to 4, or x minus 2 must be equal to 0, which means x is equal to 2. And I should always check those answers and make sure that they are legitimate. So if I put 4 into this expression, all of these logs would be possible. And if I put 2 in for x in this expression, all of these logs would be possible. I wouldn't be trying to take the log of a negative number because I can't do that. Okay. In my last one here, I'm going to start by combining these two together into a single log. Since I'm subtracting the logs, I can keep the log and divide the two values. Then I can say that I can equate their values together, and I can solve for x. Doing a little bit of algebraic manipulation, I end up with x equal to 3. Thank you, and have a good day.